This concept bite is covering some of our basic statistics, specifically averages. Now, most people will be familiar with three types of average from school: the mean, the median and the mode. But I'm also going to add in a rough and ready average called the mid-range, which is quite often used in analytical chemistry. The slide here just includes a summary of the averages. The mean, hopefully you're all aware, is the sum of all of my values that I've collected divided by the number of values I have. The median would be the middle value once they're arranged in order, the mode, the one that appears most often. And the mid-range is quite simply the maximum value plus the minimum value divided by 2. As we can see, this can be quite a lot quicker to calculate than any of the others. One thing to remember that's important is that no average can be more accurate than the measured values. When we take a measurement in chemistry, when we take a measurement in science, we're having a limit on how well we can measure that thing. I can't make that more accurate by taking multiple measurements and averaging them. Therefore, I need to think about my significant figures whenever I take an average. If we think about the mean, here I've provided a set of initial rates of reaction. I have 5 different measured values, and so if I take the sum of each of these rates and divide by 5, that gives me my calculated value of the mean, which is 1.318, but because all of my data that went into this just had 2 decimal places, I can only report my mean to 2 decimal places, giving the value as 1.32. It's important not to forget the units or any multiplying factors when calculating the mean. Something else to remember is it's often a handy shorthand to report the mean as having a bar over the value. So here I can see my notation, dA by dt with a bar over the top. My average value of my initial rate is equal to 1.32 times 10 to the minus 4 moles per decimeter cubed per second. I'm using the same set of data throughout, so here is my calculation for the median. I've lined them up in increasing order, and my middle value here is my median, 1.27 times 10 to the minus 4 per molar per second. If I have 2 values in the centre, so I have an even number of data sets, I take the average, the mean value between the 2 of them, rounding appropriately. My mode is the value which appears most often. In this data set, 1.27 appears twice. So my mode is 1.27 times 10 to the minus 4 moles per decimeter cubed per second. Finally, my mid-range is simply the minimum value plus the maximum value divided by 2. This is a rough and ready calculation designed to give an approximate value of the mean, and was considerably easier to calculate than my mean value. You'll notice here, to make sure that my significant figures are correct, I've had to round it. But to make sure I'm not introducing any systematic error, I followed the rule that I round a 5 to the nearest even number. So in this case, 1.34. The value rounds down. And so my mid-range initial rate of reaction is 1.34 times 10 to the minus 4 moles per decimeter cubed per second. Now, usually we don't use the median or the mode. It's only the mean that we care about. However, in analytical chemistry, where quite often calculations are performed on quite a fast basis, a rough and ready, quick estimate of mean can often be important, and that's where the mid-range comes into the fore. It's important to remember that sig figs are something that we have to consider. We'll learn that the significant figures and the accuracy with which we measure something are 2 fundamentally linked concepts. The one thing the mean or the average doesn't tell us, though, is about the spread of data. I have 2 data sets here, one varying between 9 and 11, the other varying between 9.8 and 10.2. They both have the same mean. They're both reported to exactly the same number of significant figures, but clearly my range on each of them is very, very different. What we need to do is we need to look at measures of spread of data, but that comes in a different video. I hope this was helpful. I'll be back with more.